All right, let's come back. Okay, I hope you can see this. Okay, let me see. First, we need to construct the circuit here. Let me compare whether it's correct or not. 1, 2, 0, 10, 5, and 6 ampere. Okay, let's construct this circuit and find the VTH and VA. It is this is going to be question number 5, the last one. Construct the circuit in figure 5b. Identify.
Sir, you not yet share your screen.
Okay, let me see. Oh yeah, correct. I haven't shared my screen yet. All right, thank you. Okay, should be okay now. Okay, identify the spelling error here. Identify the threshold voltage as VTH. What the VA referring to should be the VTH, right? The VA. The VA here should be here, right? There's only one VA. All right. Let's copy this one. Let's copy this thing here first. One step at a time. Okay, then we go ahead and draw this. As usual, we save this one. We save first, then we rename this one as Q5. So that we have. So where's a Q4 actually? Can't see where Q4. Oh yeah, right here. Okay, now let's create another one called Q5. Or we have voltage source, current source. Let's recover back here first. Let's press F9 to recover back. Okay, we need only one current source, so we just remove one. We need two resistors, so remove one also. Which one to remove? This one. Okay. Let's see we can move this one away from. Okay, this need to change. Never mind, we can do it one at a time. F7, move this one out first. And this one here. 10 ohms here. Let's use a 3 ohm here. 5 ohms here. Okay. 3 and let's change it to 10 here. Straight away, change to 10. Let's change this one to 5. All right. Now put this thing in here. F7 here. And this one should be here. That's it. Forget about A and B, just a text on me. The ground is still there. Let me double check everything's okay or not. Or here should be 120. 120 watt. Double check again. Then 6M pointing outwards. Here should be go around like this. Get a wire. Join this node. Join this node to the OB out here. Now I would remove this the text from the previous experiment. And I think it's about all. Just remove this line here, remove this line. And yeah, that's about it. Then connect the remaining wires. Oh, wait. Let me do it again. Here, and here, here, and here. All right. After this, identify the threshold voltage VA. So we need to find the voltage here. Where is it? The voltage at this node. At this node, it's called a VA. Let's put a text here so to remind ourselves. The thing in between here is the same as this node, right? It's the same node actually. Okay, let's look at step number 2. Step number 2. Where is it? Step number 2. Capture the simulation result for VA. Okay, just copy the same thing here. And it's better to copy this also. Copy this. Run the simulation. Okay, let's do it. Run the simulation. And just click on this node. 60 volt, okay? I hope it's correct. Let me press F7 and move the VA away. One more time. VA. Never mind. Just move the VA first. No, it's on back here. Never mind, I redo it again. I redo this one and click here again. Okay, so this should be presentable. Now let's copy this to our reports. Under the let me see, under the result, let's create one code, result. Okay, let me put everything in. We have plenty of time now. Let's see. Wait, how can I key something here? This is the simulation result for step 2. Step 2. All right. Next. Step 3. Reconstruct the circuit now. So what's the difference? Let me copy first, okay? Copy first. Then we look at the statement again. So you say reconstruct the circuit from A0, or A0 means A, right? I think the typo should be A. So be A. I think what it means to be like this, something like this, from A. Never mind. What A refer to? I think A is here. That means our step 1. And by removing V1, So the V1 is gone now, but we have another V1 here. So what's the reason why we need to place another 10 volt here? It didn't explain, okay? You know that this is the maximum power transfer, right? Why 10 volt is placed in the center? There's no explanation here. I also don't know why. Because maximum power transfer nothing to do with this 10 volt. Then we just follow through and see what happens. Okay, then we go ahead and remove this. Actually, what we mean remove is to drag this one to the center here. Let's look at it again. Drag this one to the center between 10 ohm and 5 ohm. Between 10 and 5, so I'm going to readjust a bit. I'm going to remove this line a bit. Then move this one aside to the left, and then so that we can squeeze in, so that we can squeeze in this circuit here. Sorry, squeeze in this component. And the other side is going to be a short circuit, right? Short circuit. So just we draw all the wire. Start from here. Then from here. Then from here to here. What happened? I keep overshoot now. Let's see. Let's do it again. Here to here. And then from here to here. Alright, the last one. Oh wait, the 6M also is no longer there, right? So he didn't mention about the 6M. The 6M is no longer there. So I think we need to modify the instruction a bit. So let me double confirm if this is correct or not. Right. The 6M is no longer there. I didn't say that about the 6M. Capture simulation of VA. You just remove it. Just remove it. Press the 10 on here. Wait. Okay. Remove 6M. Then come back to this. Rewrite the sentence here. Reconstruct circuit by removing I1 here. Okay, you say V1 and I1, and okay. So let's copy this thing here. Let's copy this circuit to the report. Because you say S below. Okay, then I think we just go ahead and run a simulation and capture the voltage VA. Okay, let's do it. Turn it off first, then run. Then it becomes 120. Wait, we haven't modified this one yet. Okay, we'll modify this one. We'll try to 10 volt. Then you'll become 10 volt apparently. Looks like become 10 volt now. But it didn't say why to use a 10 volt here. Is it because let me see 120, 10, 5, 6. Oh, I think they convert this one. the 110 and 6 ampere, 6 ampere. No idea actually. Actually, we can use a superposition to simplify this. But superposition doesn't mean we need to add a 10 watt here and see. Never mind, just follow through and see what happens. The VA, so the VA is a 10 volt. Okay, just capture the 10 watt here. Capture this 10 volt. And put under the results. Step 3. Step 3. So there's something missing here. So this is a result. VA equal to 10 volt. What's next? Oh yeah, this is the next step. So we capture the simulation result. Okay, let's put it in. That means the step 4 is to capture the simulation result. 4 is to capture the simulation result on VA. That means VA is step 4. Okay, we're going to change this one to step 4. VA equal to 10. And then, so this question looks like a new question. It's different from the one in the past. Let me double confirm again. Yeah, it's the same. It's the same. Yeah. Okay. Let's move on. Let's move on to step number 5. What is this step number 5? Where is it? Yeah. Find the IV1. So IV1 is referred to here. The current flow through the power supply. IV1. Okay. What to do? We just need to click here and then convert this one to current. Right click, convert to IV1, change this one and click this one. IV1 here. So current become 3 ampere. I think it's a round number. It's a whole number. I think it should be correct. It's a whole number. So this is the step 5. Let's copy our result to prove that we've done this step. Just copy this result. 10 volt and 3 ampere. You can show both 10 volt and 3 ampere, but 3 ampere is flowing through the V1. If you put here, it's a bit confusing, is it? Let me change a bit. Okay, this is confusing. Let's move the 3 ampere down here. Okay, because it's a current flow through the V1, so it's better to show it here than put it on the top. Okay, now we can copy it. Put under the result also, step 5. Simulation result. Set fine. 3 ampere minus 3 ampere. But usually we look at the absolute number. Right? What's next? What we need to do on 6. Or here, find the simulation on VA. Measure the value. Measure the value VA. Yeah, I think we're repeating this again and again, right? You see, this one should be up there, you see. Capture the simulation then. Right. I think this needs to be in the for previous step. So I just copy it. Otherwise, it doesn't make sense, you see. So let's put it under here. Because step 4 is to look for the VA. Step 5 is look for the IV1. Okay, so we shouldn't whatever we do has to make sense, right? And then from the simulation value, we calculate the RTH equal to V1 over IV1. Okay, let's do this. I think let's put it in first. Okay, let's put it in. Since we are now at this Microsoft Edge, we can just key in here. V1 is 10 volt. Okay, so it's a 10 volt divided by 3 ampere. So we come to resistance value of 3.33, 3 ohm. I typed the wrong. So the 3.33 ohm. All right. So let's copy the whole statement here. I hope I can put this one, squeeze this one in. A bit too big. Let's resize it a bit. Okay, about that. Okay. A bit out of position. I think it's okay. Or you have to retype it yourself. So let's say we retype it, I think it's better, right? Otherwise, it's not really awkward. See? Let's retype it. V1 over IV1 equal to 10 volt over 3 amp, 3.33. Oh, take away, let's put in 3 decimal point. Then remove the previous one. I think now it's look better, right? Actually, this one should be in the results section, I think. No harm to put another one here. Because the procedure should be procedure, shouldn't mix with the answer. But some previous they also put answer in. Some previous step they also include the answer. See, I think it's okay. Just put the underline here. Now we know that the RTH is 3.33. Okay. So that's the next step. So we need to construct this. How come it becomes 60 volt? Since when it becomes 60 volt? No idea. But we this RTH, this RL. So we need to follow exactly the same, I think. 60, but the power supply can be any power supply. Later you can put it yourself. Back to the original circuit, you put 60 volt here, and then you put the R to be 3.3. Then you measure the current. You measure the current, and then you calculate the maximum power. using this I square R formula. Then you decide whether if the R is equal to 3.33, RL equal to 33, is it the one that can achieve maximum power? Okay, so we need to just complete the last step. Let's complete the last step. Let's copy this one first. This is the last step, 7. Last another sentence. The line. All right, let's see what this says. Construct the circuit below to get Thevenin equivalent. The circuit below. So we just need to construct the Thevenin circuit now, and to get the maximum load power. I think we can construct both circuits on the same platform here. I think we can do that. Let me try it. Let me try to do this on this side, so we can look at side by side. I think this is capable to do this. So let's construct this 60 volt, because we can use our 3.3 here. Okay, never mind. Let's copy this. Let's get the. Can we copy another C? Better to get a new one component. Voltage. So let's presume we have another circuit here. But he didn't say why he changed to 60 watt. You see, this is what puzzle me right now. Since when it changed to 60 watt? And it's a Thevenin voltage, okay, but he didn't show how to get the Thevenin voltage. Here's Thevenin voltage, right? Wait a minute. The A is the Thevenin voltage. Where's A? Let me see. The step 1 should be Thevenin voltage. Step 1. Hey, where is it? Oh yeah, 60 watt. Yeah, see? 60 watt is the Thevenin voltage. Okay, so I already forgot about this 60 watt. So it's better to remind ourselves about this 60 watt. Just now we refer it to a VA, you see. That's why we kind of like overlook this VTH, or we always look at it as a VA, right? So, but here it says VA as a VTH, okay? So it's better for us to remind ourselves once again. VTH is 60 watt. This is actually the VTH. And when we have a VTH and we have the RTH, then we can simulate the another new circuit together with the RTH in series. So RTH right here, join the wire. Okay, like this until here. This is our output terminal. Then we need another ground also. Let's put in another ground. Put it here. Okay. So the result here is 3.3. So according to the maximum power transfer, RL need to be similar with the RTH in order to achieve the maximum power transfer here. This statement here, right here. So we need to insert this one similar to our 3.33 here also. Insert the 3.33. That means we need another resistor here at the as the RL. Let's change the name to RL. Let's change this one to RTH. Okay, then let's simulate the result. Okay, this one change it to value. Value should be 3.332, right? The name should be F. Okay, reverse. Okay, now everything in place. Let's simulate it. Let's find out the maximum power for the RL. Let's put the knot here. 30 volt. Okay, it makes sense, see? 60 volt divided by 2. These two are the similar value. So 60 volt will be divided by half, 50%, 50%. So become 30 volt here. So it makes sense. So just need to find out the current through this second one. So we convert this one to current. Convert to IRL. IRL. Actually, there were only one I actually. Only one I. Only one loop. Either you choose IRL or ITH is the same, I think. We'll get the same result. So it's 9.0000 by 0001. 20 and then 1. 9.01 ampere. Okay. Let's copy this result. So this is the result for the step number 8, is it? Construct to get the maximum power load, insert the value RL. This step number 7. How about step number 8? I think we place the result first. We place the result on follow this. Let's go back to copy the instruction. Here, run the simulation and capture the result for IRL. Okay, copy it to step 8. Wait, one more time. Copy and back here. Step 8. IRL. Okay. Let's do a simple step to convert it to a subscript. This will become the state number 8. So let's cut it and type in the result for state number 8. Okay, save. Now let's look at the last step, step number 9. Okay, let's copy this also. The details how to run it. Because we cannot assume that all people know about this. We have to don't make any assumption that all people knows how to get the result. So we have to put all the clear instruction in. Then we have the last step. J is not right. J is a question already. It's a typo. See, this is the last step. Use a formula to calculate the the final maximum power transfer. I don't think I can copy this square thing here. Let's try it. Yeah, I think it's I need to convert the 2 to subscript to a superscript. And then this one is the I square R, RL. L become subscript. Okay, let's do it. Let's calculate the maximum power transfer. We have cannot do it here, right? We have to do it here at the result here. So for calculation for state number 9, P maximum power output is equal to, let's copy the formula again. Copy this formula. Here. Then 9.001. 9.001. Oh. Let's do it. We do it again. Oh, wait. What is it? Press Ctrl Y to do it. And this one is considered subscript also. So let's convert back to normal. Then 9.001 square. Okay, put here like this first. Then multiply by RL 3.33 ohm equal to, don't forget to square this thing. Okay, then just use our calculator. 9.008, do it again. 9.001 square time 3.333. The maximum power transfer is 270.03 watts. Okay, this is our simulation result. Or you can say it's our calculated result. Let's do the simulation again and see if this makes sense or not. Okay. That means what we can do here is that we can come back here again. Okay, so this is our final conclusion, right? Actually, we can recover this one back to the original circuit, and then we put in 3.33 there to see whether we can get the maximum output or not. Okay, so what we do is we refer back to the original circuit. This is the one, 120. Okay, just take delete this line. Okay, another voltage source, 120 volt DC. What else? 10 volts shouldn't be here. 10 ohm is there. This one, take away this one. Okay, so this one replaced with 3.33 ohm. Presume this is A and B. So to make you see better, I have to put in A and B here so that it simply look like the original circuit. Let's do this, A and B. So we place 2.33 here, get another resistor, put in here, 3.333. Okay, then we put back everything else, remain the same. 5 ohm, 5 ohm is here, another one is 6 ampere. So we need another current source, 6 ampere. Components, current, and here, weight is pointing up. I think it's pointing upward. Yeah, pointing up. So rotate it, pointing up. Change this one to 6 amp. All right. Then we just connect all the wire and simulate. We make sure we can get the same current. Make sure we get the same current. Hold on, let's connect the last two wires. Oh, overshoot again. I think it should be okay. So slightly overshoot. I think the software didn't bother about this additional line. Okay, if you simulate, and then we check the current here. Okay, we check the current here. Okay, how to do this? You click here, and then we convert this one to current. Current output. Okay, let's choose current output. But I need to remove the dollar sign here. Yeah, I think it's still 9 point something, right? You see? It's still 9 point something. Let me pull up. Let me change the position. A bit different, but still 9.000. See? So if you think that if the user change this one to higher value, well, the user get maximum power transfer. You see, this one is the best value, right? 3.22 is the best value. If you change to higher, larger or smaller, you cannot get the maximum power. Okay, so let's go ahead and change it and see how. So this is our best solution right now. Let's make a copy. Let's make a copy before we change it. Okay, let's make a copy. Wait. What am I doing? Let's copy it and paste in our report first. Okay, we don't want to lose it, so we put it here first. Then later we come to edit again. So we put this one here is our original. Then we go ahead and increase this value. So this is the maximum power using RL equal to 3.333. To achieve maximum power output. Now we increase the 3.33 a bit higher. Okay, any number you like, as long as it's higher than 3.33, 4.333. Okay, need to run again simulation. So we get 7.82 current going through, 7.826. Okay, let's calculate again. Is it maximum power? But we better to copy this circuit actually. Better to copy this circuit before we calculate. Better to copy this. If user chosen RL equal to 4.333, means higher than the recommended. So let's recalculate the power. Square R equal to 7.826 square multiplied by 4.333. This is square equal to what? 7.628 square multiplied by 4.333. 265. So it's not higher than what? It's not higher than the recommended what? The recommended is 270. Okay, so this one we put the remark here. Put the remark lower than the recommended resistor value. Let's try go the other way. Let's try going the opposite way. Now we try to reduce this one below 3.33. Okay, let's reduce it down to 2.33 below it. See whether we can get higher or not. Then we need to simulate again. Okay, so we get 10 point. Looks like higher, right? Well, now we get 10. Just before that we get 9. Now we get 10 ampere. Okay, let's calculate again. But before we do that, we better copy it. We better copy this one. I think we can just go ahead and copy the same line here and then reuse the line and then just edit it. 2.33, 2.33, but the current increased to 10.589. 10.589. Round up to this number, 3.589. Time 2.33. See, now we get 2.33. Let's see what is the power now. What is the power now? 10.589 square it, then multiply by 2.333. 261 only. 261 watt. So the conclusion is very clear. By using the maximum power transfer, the first solution, 3.33, to achieve the maximum power transfer, where we can get 270 watt. Is surely higher than the 265 and 261. That means in the future, when you try to calculate the maximum output of certain device, if you can find their Thevenin equivalent resistance value, you just make your output similar to that internal value to achieve the maximum power transfer. This is true when you're using the something application like the speaker. You know, the speaker, you need to match the impedance. Let me show you the how to apply this concept. So if you want to achieve the maximum speaker output, match your speaker ohm with the power amplifier resistance value. Let's say your amplifier resistance value here, the equivalent resistance, the RPH is 4 ohm. Then you better use a 4 ohm speaker. Okay. If your internal resistance here is 8 ohm, then you better use 8 ohm speaker. Okay. So how about if the circuit is 4 ohm, but you only have 8 ohm speaker? That means you need to use a transformer. Use a transformer to transform from the 4 ohm to 8 ohm. Then you can do the matching like this. Then you can achieve the maximum power transfer like this. The internal is the 8 ohm. The speaker uses 8 ohm. Therefore, you can achieve the maximum power transfer. So if you use anything less than that, you'll not get 100%, you see. So that's why when you're choosing a speaker, you need to ensure if you want to ensure maximum output, you need to select the right impedance side for the speaker. Okay, so the speaker usually comes with a 4 ohm, 8 ohm, 16 ohm, 32 ohm. So it's for you to do the matching. So you need to select the right one. So this is how we apply it. How we apply this one on the real case, the real daily circuit. So what is this? I think this explains everything, right? So you see, we have a speaker 2 ohm, 6 ohm. So you need to do the matching if you want highest output. Otherwise, your speaker look really weak. You will not output the output that you're looking for. Okay, that's about all. Okay, I'm going to keep this this session until 7. If you have any question you want to ask, you can go ahead and ask the question. But actually, we have already done all the lab here. Okay. And what you need is just another discussion and conclusion. All right, that's all, guys. So thank you for staying with me until this time. It's a long day, really. So if you think that you understand all, then you can now leave anytime. You know, the class is almost over, I think. But I have to keep this one until 7. You know, I have to keep this line open until 7. So if you still have any question, you can feel free to ask me right now. If any part of the circuit, but we have limited time, you see. We have until 7 now. If anything you still not understand it. So just now there's one student asking whether should I share this one with you. You know, in the past I do share with the student, but at the end students use it for their assignments. See. I prefer you to type it, and if you really want me to share it, I can do that, but I have to remove all my screen capture. I only leaving all the words behind. I leave all the words behind, but I have to delete all the screen capture. Or it doesn't. At least when you cut and paste from the video, it's almost the same, see. But I think it's better not to share with you. How about the screenshot? You mean which one? Which one not complete yet? Which one? Lab 1? Lab 1, what do you mean not complete? Let me see it. Which part is it? You mean the theoretical value? You mean the this theoretical value? The theoretical value you have to calculate yourself. Okay. The simulated value will already have everything here. The voltage across each resistor. You need to find it from the let me see to find the voltage source. The voltage across each resistor. You can put the node there to read the voltage node. You see, is it what you're referring to? Yeah. Uh, uh, of course, you see some of the question are not completed because you still lack the tutorial 2 and 3. After you attending the tutorial 2 and 3, then you can come back and solve the theoretical value, right? So this is what this is so far the how far we can get today with the knowledge you have after tutorial 1. To complete the rest, you need to attend tutorial 2 and 3. Then you come back here to fill out all the blank. Okay. Just now, I think the student referred to the incomplete lab 1. I think you can do it this way. Let me show you. Let me show you. Let me save this one first. And then if I bring out the my lab 1 again, you can see you can just click here and read all the voltages. See, and this voltage for R4 is a 1.214. So you can go ahead and fill it in here. Voltage for R3. Voltage for R3, you have must be a difference between the voltage difference between these two nodes. So take this one higher minus the lowest value, then you can get the voltage between these R3. So once you have this circuit done, you almost have all the value here. See, the only thing lagging is the the calculated, no, it's the theoretical value here, theoretical value. This one, you need to learn a few techniques. At least you need to learn the KCL, KPL. Then you learn how to calculate this value. It's same for some other question also. Some other question you need to also find out the theoretical value. Let me see which one is it. This one is easy. This one I can show right away because you need only 2 registers. I can show right away how to calculate the theoretical value. Theoretical value. But for the next question, question number 3, let me see. Yeah, this part you need to attend tutorial 2 and 3. Then you can know how to fill out this form, how to fill out this blank here. Okay, guys. Of course, we couldn't get everything done today. No. All right. So the another question is the A1 assignment. I mean the assignment number 1. You see your due date is on the 9. If I remember correctly, your due date is on the 9. Okay, on the 9. And then our next class will be, wait, let me see here. My next class will be here. Let's look at this. It's on the October 1. You see? See, the coming October 1, we're going to go over your assignment 1 because after this you need to submit it, right? But this assignment 2, the due date is until November. See, it's not even on the list here. Way beyond the last tutorial. So you still have plenty of time to prepare for this assignment number 2. This considered assignment number 2. We still have plenty of time. So what we should worry about actually is the coming October 1, where we need to settle the assignment 1 questions. Make sure you all know how to deal with the questions. Okay. Of course, we couldn't get it done today. Today is specially designed for the assignment 2. Okay, guys, is it clear? So you if you're really concerned about your assignment 1, so I encourage you to attend the next tutorial, which is going to be held on the 1st of October, where we will take some time to look at all the questions. All right, guys, is it okay? All right. So you can leave if you feel that you have done everything. And I'm going to stay here and keep this open until 7. Then I'll shut it down. All right, guys, thank you for staying with me for the whole day. Luckily, you need to do it once. I think do it once in the whole year. I think you got to repeat again. All right, guys. If you can stay from 8 until now, see, it's quite an achievement already. I think to stay at 10 hours continuously to work on this project. Okay, after this, it's better to get a nice meal and then so that we can recover back all our energy. All right, guys, thank you, but I have to stay here. Okay, you can leave anytime you want. Okay, remember to put down your name. So I'm marking your attendance right now. All right, remember to put down all your name.
Thank you, sir. Thank you, sir.
Yeah, thank you. Okay. I see where. Wait. Oh yeah, I should scroll all the way out. I think it's better for me to use the. Is there a better way to do this? This is another painful process. Oh yeah, this is the previous slide. I need to refer back to the Lab 1 again. I need to refer back to the Lab 1 to see the all the name there. Where should I? Yeah, yeah. Also, Teo Zhen Chong. I think just now I bought Teo. And this one. Let's scroll the way up. But see previous reply. This is not very user friendly usually. Okay, this is a big beginning. Then I start from here. Yong. So Yong. Okay, not already. This is not very user friendly. So this student is not on the list, I think. Yes, on the list. Okay. Lesson. It's not on the list. That's why I put it here. I should put it here. Oh yeah, this one's on the list. Yeah. That's what else? Lee Her. Okay. Lee Her here. Already mark. David. David. I believe David Phillips too. David Phillips here. Already mark. John. John's not here, so I need to put your name down. Name here already, right? John here. John Kim Son. And then Gabriel. I think last one is Muhammad Hafizi, right? Hafizi. Let's go all the way down to Muhammad Hafizi. Yeah, so I start from here, Garnison. So let me go through this one at a time. And this student. Some of your name are not here because probably due to the registration issue. They forgot to, they are unable to update it. Let's see. Let me put your name here. Oh, no like this. Let me move for it. Better to make a copy now before I lost everything. I'm gonna redo it again. Where is mine? Let's do this one. Words. Okay, let's see the next one. Oh, are you still here? Let me see. Lolan. Yeah. Okay. Wow, some of your names are not easy to pronounce. David here. Yeah, I can see your name. Jim. Here, let's see. Then, yeah. No more here. No more. And now one more. More. Here. That is. So if I overlook your name, let me know now. See, so I can mark it directly. So no, not from here. It's strange, huh? I copy your name just now, but I can't paste it. I overlook anyone's name. No more, right?
Sir,
Anyone else? What's your name?
sir, my name is Gordon, but I can't saw my name in the list.
Can you type your name?
Uh,
Can you type your name here so that I can copy and paste?
okay.
Yeah, type your name
In
right
lab
here.
1 or lab 2?
Both is okay.
Both.
I'll
Okay.
do it. You type your name here. I think I already entered all this name, so don't worry.
Already entered.
Golden, yeah.
Yeah.
Put it here because I couldn't find your name here. See, anyone else who your name is not on the list? You let me know now so I can mark because I already go down to the end of the list. This one that I think first time I see this Bonaventure. Yeah, your name is still here. Your name is here. Anyone else I miss? Yong Sui Yun. I think I already checked this one, right? Yong. Yeah, I already checked. Yong Sui Yun. This is right. Okay. Then let me capture another. Yun. One more time. This is the one. Yeah. Okay, guys. Any question? Otherwise, I think you feel free to go now because I need to stay here. Another one, Lauren. I think Lauren I already keen, right, Lauren? Because I have to stay here until 7. I cannot leave early. I have to stay here. Lauren. Yeah, it's here. Lauren is present. Yeah. I have to stay here, see, until 7. But it's almost time now. Another 10 minutes. All right, guys, have a good day. Have a good night. It's almost evening. Now it's a good evening. Okay. Enjoy the rest of the time for this weekend. All right. I let me mark the other one also. You see, we have morning and afternoon class. This class is a morning one. I think this is a morning one. Yeah, this is a morning one. I have another one to fill in also. The afternoon one. Yeah. So I need to redo again. But first I'll copy your name here. Okay. Then I redo everything else. I need to compare side by side. Number 2, 3, 4, 2, 3, 4, 5. Okay, 2, 3, 4, 5. 4, 5. Then 7 and 10 to 13. 7 and 10 to 13. 7 and 10 to 13. What's this? 14. 14 also. 14. This is a 16, 16 and 18. 16 and 18. 16 here, 18 here. This one, this 18, 20, 21, 21, 22, 21, 22. Wait, where's 22 here? 22 here. Wow, now in the row here. From 27. Okay, 27. Okay, where do we end? Okay, everyone still here? Okay, we have a couple students left. Okay, I just submit this one already. Submit it. And this one, whether I can submit or let me see. Let's try submit. Yeah, can submit. Okay, I gotta wait until here. I think some of the guy probably they are not in front of the office, in front of the PC. You know what, I'll just stay here until 7. I think it's almost time already. I think it's okay for me to just leave it almost time. Never mind, I just wait until 7. Wait until 7. Wait, that man stop recording.